All right, guys, we're going to move on to the second half of the 8.7 factoring special products. Okay, so we left off here with factoring perfect square trinomials. Okay, so this is another strategy for specific types of quadratic equations. This one is not as important as the last one to really memorize and know, but it can definitely come in handy later on, so I recommend that you practice it and practice looking for it. So this is called a perfect square trinomial. What a perfect square trinomial is and this will make more sense when we get into graphing these, but essentially what it is it's when you have a perfect square as your first term, a perfect square as your last term, and the middle term is 2 times the root of those two things. Okay? So here's what I do when I'm trying to evaluate whether or not something is a perfect square trinomial. By the way, using just regular factoring techniques, you guys, you could do this without any of this. So just factor it like you would any trinomial. So you ask yourself the question, first of all, is there anything that comes out of all three? No. So then you look at the last term. It's 16. Okay, so what two things multiply to give you 16, add to give you 8? That would be 4 and 4. So this thing would factor to x plus 4, x plus 4. Okay, so we know that by that regular strategy, okay? So now I'm going to erase that. Okay, so we're going to erase this. And let's go back and use the new strategy. The new strategy says this. If the first term is a perfect square, if the last term is a perfect square, and the middle term is 2 times those roots, then we know that the factors are the square root of the first one, the square root of the last one, okay, using the sign that is in between. Okay, so this would be x plus 4 squared, or x plus 4, x plus 4. Okay, so the strategy here is to use these questions on the side. Okay, is the first term a perfect square? In other words, can it be written with parentheses? Can you write this as something in parentheses squared? And the answer to that is yes. It could be written like this. Then you do the same thing for the last term. Can it be written as something squared? The answer is yes, 4. Okay, if that is true, and then this times 2, if that is the middle term, okay, then I know that I'm dealing with a perfect square trinomial. All right, so this thing will factor to x plus 4, or x plus 4 squared. So that's kind of the teach. Don't get too discouraged if you're still struggling with this. It does take some practice. Let's do a couple of examples. So example 2 says, determine if it's a perfect square trinomial. If it is, factor it. Okay, so here's the steps. Can I write this first term as something squared? Okay, so I'm going to check that, and then I'm going to do the same for the last term. Okay, so the square root of 9 is 3. The square root of y squared is y. So 9y squared is the same thing as 3y times 3y. 3 times 3 is 9, y times y is y squared. Okay, so that can be written as something squared. 16 can be written as 4 squared. Okay, so then I check this. 3y times 4 times 2. Does that equal 24y? Well, 3 times 4 is 12, times 2 is 24. Yep, 24y, it does indeed. So the answer is yes, this is a perfect square trinomial, and the factor is this thing, 3y, with this sign plus this thing squared. Okay. Sorry if this looks a little funky here, but this should be a 3. There you go. Okay. So So that's example 2a. I encourage you to try 2b on your own and then pause the video and then come back to it, but here we go. So can I rewrite 2a squared as something squared and 25 as something squared? Well, this can be, but what times itself gives me 2? There is no square root of 2. I mean, there is. It's some kind of decimal, right? So there's not a nice number that we can use for the square root of 2. So this thing is not a perfect square trinomial. 2a squared is not a perfect square. Okay, nothing times itself gives you 2, except for some crazy decimal. So the answer to this is no, not a perfect square trinomial. Okay. Keep cruising on to example 4. So example 4, they're going to give you different types of quadratics now. They're going to ask you try out a strategy and see if you can factor it. So there's a number of strategies out there, and I think I've given you a number of them on your notes. The first strategy you always use is, can you take something out? Okay, so distributive property. So we're going to try the distributive property first. We always check to see this. Is there anything I could take out of all the terms? And if so, then maybe that's all we have to do to factor. Okay, so let's look at the first one. Can I take anything out of this? Well, they're both even, so yeah, I can take a 2 out. If I take a 2 out, I'm left with x squared minus 16. Okay, some people would be tempted to be done, but if you ever see a squared term in your answer, you should always check again. Okay, there are 2 pieces here with a minus sign. You should be starting to identify that that could be a, if there's 2 pieces left, a difference of squares. Okay, this is another thing to check. So in other words, can I write this as something squared minus something squared? And the answer is yes, x and 4. Okay. So this thing can be factored to, this is going back to the previous video now, okay, this can be factored to 2 times x plus 4, x minus 4. All right, because it's a difference of squares, and a difference of squares always gives you this piece and this piece, one with a plus sign, one with a minus sign, so that the middle term disappears. Okay, let's look at 4b. Okay, first of all, can I take anything out of all 3 pieces? And the answer to that is no, I cannot. Okay, so the distributive property I'm done with. There's not 2 terms, so it cannot use a difference of squares. I really don't want to try to factor this the long way, just a standard factoring of quadratics, but I might have to. Let's take a look. So for 4b, can I write this as something squared? Can I write the first term as something squared and the last term as something squared? Well, let's try the square root of 12. Nope, square root of 12 does not give me a nice number. Okay, so on 4b, we're probably going to have to go the long route. Okay, so let's see if we can figure this out. So this is going back to what we learned back in lesson 8.6 now, factoring quadratics. So for this one, since we do not have a 1 out in front here, we're going to multiply the first term by the last term. So 12 times negative 25. And when we do that, we get negative 300. Okay? So we're asking ourselves, what 2 things multiply to give us negative 300, add to give us 5? Okay, that's going to take a little while to figure out, but if we look at the factors, we know that 1 and 300 is not going to give us 5. Neither would 2 and 150, so it's going to have to be 2 things that are close together. I'm going to try like 15 and 20, okay, because I know 15 times 2 is 3, so that would work. And yeah, the difference between these is 5, but I have to figure out which one's positive, which one's negative. I need a positive 5, so this would have to be negative, this one would have to be positive. Okay, so again, we can't use a perfect square trinomial, so we're going to factor the long way. So this becomes 12x squared minus 15x plus 20x minus 25. Okay, and then I use grouping. Okay, what two things are in common here? We have a 3x, and then what's left is a 4x minus 5. Here, take a 5 out, and I'm left with 4x minus 5. So my factors are 3x plus 5, okay, and 4x minus 5. All right, now, we're going to keep cruising through a couple more examples here. Sometimes you have to apply a technique more than once. So here, for 2a, can you write that as a difference of squares, or something squared minus something squared? And the answer is yes. Y squared squared gives you y to the fourth, and 1 squared gives you 1. So I can write this as y squared plus 1, y squared minus 1. Okay, this is done because this might be two perfect squares, y squared and 1, but it's not a difference. This one, we have a different sign. We have a minus sign, so I can factor that one again. So in our final answer, we'll have x squared plus 1. That's part of our answer. But then we can factor this one again. Okay, I can write that as y squared minus 1 squared. So it would be y plus 1, y minus 1. Again, I'm just taking these two pieces, y plus 1, y minus 1. Okay, so that's applying a technique more than once. Here's a couple of examples of when you might do that. So for 5a, the first thing you're always going to want to ask is, can you take something out of both? And the answer is yes, 2. So then I'm left with y to the fourth minus 25. Okay, here I'm going to check for a difference of squares. I can write this as y squared squared minus 5 squared. Okay, so then I have 2 times y squared plus 5, y squared minus 5. And then I'm done because I do not, even though this is a difference here, the y squared is a perfect square, but the 5 is not. So I'm done. Cannot factor that further. Okay, then for 5b, we'll do the same thing. All right, can I take something out of both? Yeah, 6 goes into both. So then I'm left with x to the fourth minus, let's see here. How many times does 6 go into 96? Let's just do it longhand, old school, because I don't know that one off the top of my head. I should, but I don't. 16. Okay, so I have this. Again, check for a difference of squares. We still have the 6. I can write that as x squared squared minus 4 squared. So that would be x times x squared minus 4, x squared plus 4. This one is done because we have a sum, but this one we have to try it again because we have a difference of squares, so that becomes x times x plus 2, x minus 2, and then we still have our x squared plus 4. These are going to take some practice, you guys. I know I'm cruising through this pretty quick, but I'm trying to keep these videos short. I'll answer questions in class for sure on Zoom. Okay, so for example 5c, this is the last one we'll do, and then you guys are set to do your homework. Whenever you have 3 terms, or more than 3 terms, you guys, you are going to group. Okay, grouping is the strategy when there's more than 3 pieces. Here we have 4 pieces, so we're going to group. Okay, we're going to group these together, group these together. Okay, so what's in common with the first 2 terms? Well, in m squared. Okay, so I'm left with 2m plus 1. Okay, in common with the second piece is a negative 25, and then I'm left with 2m plus 1. Okay, so the 2m plus 1 can be factored out, and then I have m squared minus 25 left. Okay, this you should recognize as a difference of squares. So I have 2m plus 1, which is still there, and then that can be written as m plus 5, m minus 5. All right, and you guys have homework sheets that are attached to Google Classroom. I'm probably going to give you multiple days for this because this is just very involved. but see what you can do with this, and then we'll go into our review, and then we'll be taking our test for Chapter 8. All right, guys, I'll see you in class.